This is example 5.3.4, and what it's doing is it's relating this Newton's second law to stuff that we learned earlier this year. So if you look, it says a car is accelerated from 10 to 20 in 5 seconds. You should realize, hey, that's acceleration right there. I'm going to have to use if that. And also, it says that if a car has a mass of 1,000, what is the force that is produced? So I'm also going to have to use Newton's second law, which is F equals ma. So all in all, what I'm trying to do is I'm trying to determine the force produced by the engine. And here's another thing. It says assume no friction. So really when I'm looking for the sum of the forces, that is, in fact, the force applied by the engine, because there is no friction in this particular case. So if you look at what's given, I'm given, we do our if that, I, F, D, A, T, and the initial velocity right here is 10. The final velocity it gives me is 20. The time is 5 seconds. So the key to this particular question, you look at it and say, well, why would I want to do this? I'm trying to solve for force. Well, the key to this is we're actually missing the acceleration term. In order to calculate force, I need to know what the mass is so that I can go ahead and solve for the acceleration. Or excuse me, I know the mass, but I need the acceleration to solve for force. I can do that with the if-that equations. If you look, I can solve for acceleration. That means that I don't have or care about distance, so I'd pick the equation that doesn't have distance in it. And remember, that is A equals VF minus VI over delta T. Or in our case, 20 minus 10 over 5. That right there is going to give us an acceleration of 2 meters per second squared. So once you have an acceleration of 2 meters per second squared, you can now take that value and you can plug it into Newton's second law, where we already knew that the mass was 1,000 kilograms. So we can say the sum of the forces, or the applied force in our case, is equal to 1,000 kilograms times an acceleration of 2, or 2,000 newtons.